Hey there! So here is a project that I just finished, and it involves adding audio functionality to this 3D companion cube that I designed and printed out a few months back. The goal of this project was to make it so that whenever the cube detected an acceleration, it would play back a random sound file from the Portal games, like so. So it's pretty interesting and all, but the goal of this video is to do a disassembly and to show what is it like inside. So we'll go ahead and do that. And the cube is nice in that it is completely modular, so we can take these panels off.
In case you're interested, there's still some positions available for that bonus opportunity I mentioned
It's
earlier.
playing
Again,
stuff because I'm
all
moving
you
it
gotta
around.
do is let us disassemble you. We're not.
And then there's a on-off switch here, so we can turn it off to save power. And the neat thing about this is that I optimized all the parts and such that when it's an idle, so when it's on and it's not playing anything, it only draws 500 nanoamps. So off of this 400 milliamp hour battery, lithium polymer battery that I have back here, I can actually power this cube for over 100 years. Not like the battery will ever last that long, but assuming a fully charged battery, it will last quite a long time. When it's playing back though, it will draw about, I think, an average of 50 milliamps, and so that will only last the battery about 8 hours or so. But continuing with the disassembly here, we can take off the panels. Here are the two panels here are the ones with the speakers. There's one with a short cable, one with a long cable. The one with the short cable plugs right into, right across from the amplifier, and the longer one has to wrap around. So we can unplug the longer cable and run it through the casing. And then we can sort of pull this out like so, and there you go. The two speakers are out. Now these speakers are glued onto the panel with JB Weld, so they're pretty strong. I cured it for 24 hours, so it's about as strong as I can get. They do take two screws, which I decided not to use because that would have required me to drill 2 holes in the panel, and I didn't want to do that. So I'm hoping that the epoxy is going to be strong enough such that it won't fall off eventually due to all the vibrations from these speakers. And these are audio transducers, so they're not actually speakers, but what they do is they vibrate, and in this case, it'll vibrate this entire panel to generate the sound. So it's using whatever it's attached to as the diaphragm, sort of. And that's because I tried using smaller speakers, and first of all, it's very difficult to fit speakers into this case, and second of all, when you have a traditional speaker in here, it was very difficult to hear when the cube was covered up with all these panels. So using these transducers allow for pretty loud audio to be played from within the cube. Put those aside, and here's the main cube. It consists of the internals. Consists of a frame, 3-piece frame, as well as 3 of these proto boards from Adafruit. And I didn't have much time to work on this project, only about a week and a half or so. So I had to use these boards to quickly put it together so I can get this project shipped out in time. To take these inner boards out, we have to take apart the frame here, and to do so, we rotate the middle frame, the one that holds these boards together, we rotate it about 45 degrees ish, so it looks like that. And by doing so, we make it so that we can actually bend the plastic to remove this one frame piece, like so. So we're taking advantage of the flexibility of ABS here, which is rather nice. And so here's the middle piece that just came off, and then we have these 3 PCBs in the middle. So I'm going to first take off the battery charger, which I've attached on here, so that you don't even need to detach the battery in order to charge it. You can just take this USB charger off, plug into any USB port, and it will charge it straight from the USB port. And to take these to take these three boards out from these two frames, we actually have to take the well, here's the micro SD card that popped out. But we first have to take the microcontroller board. So these three PCBs are divided into three layers. The top layer contains the amplifiers for the transducers, and these are 1.7 watt amplifiers into 8 ohm speakers. We also have the accelerometer, an ADXL 345, which is used to detect the tapping motion in order to trigger the audio. The middle board is a VS1053B audio decoding chip that the microcontroller will read the audio files from the SD card or the micro SD card and then send it to this audio decoding chip for decoding and playback. So to take the bottommost PCB is you can't see it very well, but it's the microcontroller board. But we're gonna go ahead and take that out to show what it looks like. To take it out, we can just pop it out, and I made it so that the bottom piece is actually modular. You can pop it out relatively easily, and just like so. So here we are. We have the MSP430 that is acting as the brains of this project. We have two LEDs just for indication, and we have a 1.8 volt regulator for the digital circuitry on the audio decoding chip. And that's pretty much it. It's pretty simple. All the pins are broken out and onto this board as well, and so you can see that it's fairly convenient, making it so that it's detachable. And then we have the other two pieces. Unfortunately, none of the other stuff, you can take it out, but there's not much point in doing so, as this is pretty much it. There is a 3.3 volt regulator here for the lithium polymer battery. And there is again, as I mentioned earlier, an on-off switch in case you want to keep it off for long periods of time. So we'll go ahead and reassemble this by simply taking this bottom piece, and we'll go ahead and put it back in just like so. And it's made so that it can only be inserted in one way. So if it doesn't work, try rotating it around and it should fit right in, just like that. And then we can rotate this a little bit, and then we can put our third piece for our frame back in, and it will just slide right over. See if I did this right. It will slide right over. We just have to bend a little bit so that it will actually fit over these pieces of plastic, just like so. And then we'll rotate the middle frame again so that it will snap into place. Might have to jiggle it a little bit just so that it moves nicely. And there you go. Once it snaps into place, we should have all three pieces. Just like that. Then we're going to go ahead and stick this charger back in so that so the wires don't prevent us from putting the panels back on. And then we can start putting the panels back on. The first one that should go on is the one with the long wire, and that goes in right here like so. So we're gonna have to run this cable, run around the edges, and there's plenty of space for the cables to run. So we'll just kind of run it through like this, put the panel on, and we'll plug it into the leftmost plug in the amplifier, and we'll just kind of plug it in like that. Okay, so that's one speaker on. The other speaker is really easy. We just put it in and we plug it in, and that is it. We don't even have to run any wires. And there you go. And now we can put, well, that we have the speaker panels in, we can put the rest of the panels on. and then we can turn it on. And when you turn it on, it'll actually play the theme music or the ending music from the game Portal, and that is hard coded in. It'll play the first track. You can actually change the tracks if you want, and once it's done, it'll go into sleep mode where it'll listen for movement, and when it takes a movement, it'll play one of the random tracks on the micro SD card. So that's it for this project. Hope you enjoyed watching, and look forward to some of the other stuff that I have going on that I'll be posting relatively soon.